Hi everybody, this is Miss Bufford and this is video number 1 over acids and bases for our distance learning unit. Your learning goals for this video are to be able to identify Arrhenius acids and bases and to recognize acids and bases by their formulas and their characteristics. The Arrhenius theory of acids and bases describes the acid-base reactions that occur in aqueous solution. Arrhenius acids are compounds that dissociate in aqueous solution to produce hydrogen ions. So if you take a look down here in the pink box, I have some examples of Arrhenius acids listed. You'll notice that these compounds, once we dissolve them in water, will produce a positively charged hydrogen ion and an anion, depending on what the identity of the original substance was. For example, this first one, we've got hydrochloric acid, or HCl, hydrogen chloride, and we dissolve that in water and it produces hydrogen ions and chloride anions. Okay? Then on the other side, we've got Arrhenius bases, and an Arrhenius base is a compound that will dissociate in aqueous solution to produce hydroxide ions. And then if you look in the blue box down below that, you'll notice there's 3 examples of Arrhenius bases listed. The first one, sodium hydroxide. If we dissolve that in water, it produces a positively charged sodium ion and that negatively charged hydroxide ion, just like the rest of these examples. All right, now let's talk about recognizing acid formulas. Arrhenius acids have acidic hydrogens that are listed in the front of their formulas or at the beginning of their formula. Acidic hydrogens are the hydrogens that are going to dissociate in aqueous solution. So if you take a look at all of these acids, whether they're listed under the strong acid or weak acid, you'll notice that the hydrogens in all of these formulas are listed in the front. So these are the hydrogens that will be dissociating. And I also, so I do have these organized according to whether they're strong acids, which like strong electrolytes will completely dissociate in aqueous solution, and weak acids, which will incompletely dissociate in aqueous solution, right? So for example, if we take a look at these 2 beakers that I have listed here, the first one that says strong acid, we can see that there is HCl or hydrochloric acid dissolved in there, and that those particles have all completely dissociated into individual particles. So I've got hydrogen ions and chloride ions floating separately from one another in there. And in the second beaker, labeled weak acid, I have an example of a weak acid, which is hydrofluoric acid. And this is weak because it does not completely dissociate. So some of these units of hydrofluoric acid are staying together, and we have one that's actually dissociated. So only partial dissociation in weak acids, just like weak electrolytes. And acids are electrolytes, and so you can see that both solutions are conducting electricity, but the strong acid is conducting more electricity because it has more ions in solution. One other piece of information that I've put on this slide for you guys is that if you take a look at the pink brackets, the large pink bracket is pointing to all of the acids that have a single hydrogen listed in the front. So all of those only have 1 hydrogen. These types of acids with only 1 hydrogen are called monoprotic acids, and it's just because they have 1 hydrogen. And monoprotic means 1 proton. So when we talk about hydrogen ions, in the past I've told you that a hydrogen ion or hydrogen atom itself only has 1 proton in its nucleus, and when it loses its electron, all it's left is that proton. So a positively charged hydrogen ion is really just a proton. And so we say that these are 1 proton or monoprotic acids. For sulfuric acid, which is the only diprotic strong acid, it has 2 hydrogens, and so we call it diprotic, or 2 proton acids, because it has 2 hydrogens. And then under the weak acids, I have an example of a triprotic acid because it has 3 hydrogens in its formula. Okay? Now let's talk about how to recognize base formulas. Arrhenius bases are ionic compounds that contain hydroxide polyatomic ions and are soluble in aqueous solution. So in order for a compound containing the hydroxide polyatomic ion to be considered a base, it has to be soluble in water. There are a lot of compounds that contain hydroxide ions that are ionic, but they do not dissolve in water, and so those cannot be considered Arrhenius bases. So what I have listed here is a list of the most common strong bases. There are more than are listed here on this page, but these are the most common ones. And then I'm giving you an example of a weak base. And what separates the strong bases from the weak bases, just the same as the acids, is that strong bases will completely dissociate in aqueous solution. So if you take a look over here at the beakers, in this first one labeled strong base, I have sodium hydroxide dissolved in here, and you can see that sodium hydroxide has completely dissociated into particles, charged particles or ions in solution. And if you take a look at the second beaker labeled weak base, I have ammonium hydroxide in there, and you'll notice that most of those units of ammonium hydroxide are still paired up, but I have some ammonium hydroxide, one unit that has dissociated into positively charged ammonium ions and negatively charged hydroxide ions. One other way that we can identify acids and bases is by looking at their characteristics. And so we're going to go ahead and look at some characteristics of both acids and bases. And so the first characteristics of Arrhenius acids, and remember these are solutions that contain high concentrations of hydrogen ions, are that they are sour tasting. So an example would be a lemon. Lemons contain citric acid, which is known to be very sour. They're corrosive to metals, and so what this means is that they react with metals to release hydrogen gas. They can actually, dissolve a metal. They conduct electricity in aqueous solution. So just like we talked about on the previous two slides, is that acids are electrolytes. We can classify them as either strong or weak electrolytes. And then one other piece of information here is that litmus paper is actually an indicator that lets us know whether a substance is either acidic or basic. And you can get litmus paper in both blue and red in color. If we have blue litmus paper, an acid will turn that red. And if we have red litmus paper, the acid, it's just not going to change the color. It'll just be red in an acid. So characteristics of Arrhenius bases. And remember, these are solutions that contain high concentrations of hydroxide ions. These tend to be bitter tasting. And they tend to feel slippery on your fingers or on your skin. So if you get hydroxide or something that contains hydroxide ions on your skin, then those hydroxide ions are going to be reacting with the oils in your skin to produce a soap, and that's why it feels so slippery. Again, these will conduct electricity in aqueous solution because they are electrolytes. And just like the acids, they can be classified as strong or weak. And a base will turn red litmus paper blue. So if we start off with red litmus paper and we touch it to a base, it'll turn blue. If we start off with blue litmus paper and we touch it to a base, it will stay blue. So blue is for base and red is for acid. All right, I hope this video was helpful. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.